Muy buenas tardes a todos y bienvenidos a este curso online de cálculo biométrico organizado por Zeiss. Para todos aquellos los que no pudisteis estar con nosotros la semana pasada, recordaros que estuvimos con el doctor Castro, que nos habló de la selección de fórmulas según los parámetros oculares, y hoy abordaremos el segundo módulo de cálculo biométrico en córneas posoperadas. Mi nombre es Elisa García, jefa de producto en biometría y microscopía para Zeiss, España y Portugal. Y sobre todo, hoy me gustaría recordarles que el lunes van a recibir la grabación, los dos módulos grabados y subtitulados en los correos que nos han dejado en su inscripción. Y también recordarles que tienen activo el chat para poder realizar todas las preguntas que requieran y poder transmitírselas al doctor invitado y ponente que tenemos hoy. Es un ponente, como saben, internacional y por ello, si me permiten, con su permiso, voy a cambiar ahora de idioma para poder presentarle. Dear Doctor, I would like to present our guest speaker of today, Giacomo Savini. Nice to have you here. Dr. Savini is well known for all of us, national and international context, for his numerous studies, presentations in congresses, and as well because he's a really known research. Now, Dr. Giacomo Savini is working in Studio Oculistico di Azeglio in Bologna, and as well is executive member of EOL Power Club, and as well member of Italian Association of Cataract and Refractive Surgery. Dear Giacomo, welcome to our webinar. It's a really great pleasure for us to have you here.
Thank you, Elisa. Thanks, Zeiss, Spain, and it's my pleasure to be here. I started my collaboration with Zeiss many years ago, and Zeiss always supported me in my clinical studies, in the research, and in many courses that I've been giving. So today, I'll try to give some suggestions on how to calculate the IOL power in eyes that received previous laser vision correction as well as radial keratotomy with some clinical cases at the end. And I'm gonna share my slide. Just a second.
Perfect, Doctor. I will stay here just in case the audiences have any questions, and I will go back to you with the questions, okay? So all the panel for you. We can see perfectly your presentation.
Okay. So when we talk about IOL power calculation after laser vision correction, we should first try to understand not which is the best method to calculate the IOL power, but why is the IOL power wrong, and why can we have errors if we do not take into account the previous cornea surgery. So which are the sources of error? And there are three main sources of error. The first one is called the keratometric index error. The second is the measurement radius error. And the third is the formula error, either ELP prediction error. So let's start from the first one, the keratometric index error. We know that all devices commercially available developed to measure the corneal power actually do not measure the corneal power. They rather measure the corneal curvature. So they give us a radius in millimeters, and we have to translate this to convert the millimeters into diopters, into a power. And this has been usually done just from the anterior corneal radii, because until about 15, maybe 20 years ago, we were not able to measure the posterior corneal curvature. So the formula to calculate the power of the whole cornea, so the anterior and posterior power just from the anterior radii, is this one, the first one you see, where P, the power, is equal to n minus 1, where n is the corneal refractive index, minus 1, which is the refractive index of air, divided by the anterior corneal radius. and n, which on most devices is equal to 1.3375, is the so-called keratometric index, which is a fictitious number. It's not real. It's not the real refractive index of cornea. It's just a number that was invented probably 200 years ago uh, to calculate the total corneal power, or better, to estimate it just from the anterior radius. And it has a specific feature. It depends on a constant ratio between the anterior and the posterior corneal curvatures. And here immediately you can understand what happens after either myopic or hyperopic surgery. Both LASIK and PRK change this ratio, the ratio between the anterior and posterior curvature, so that this index, 1.3375, is no longer valid. And here you can see an example with a topographer, and you see that according to the machine, the mean keratometry is 34.33. But if you recalculate according to the method that has been later adopted in the Hofer QST formula for post-LASIK eyes, it's much lower, it's 33.48 diopters. And we published the method to estimate this K in 2007 on JRS. And what happens after radiokeratotomy? For many years and on many books, it has been said that since both surfaces flatten, the keratometric index is still valid because they flatten in parallel and the ratio was supposed to be maintained. This is not true. Back in 2012, using the pentacam, we were able to demonstrate that the ratio changes, and it changes in a direction which is opposite to what happens after myopic LASIK, because while in the myopic LASIK the flattening is more relevant on the anterior surface, actually it happens only on the anterior surface. In radiokeratotomy, the posterior curvature flattens more than the anterior, so the ratio, you see that while in normal eyes is around 1.22 with the pentacam and most shunt cameras, it goes up to 1.34 after myopic LASIK or PRK and goes down to 1.12 after radiokeratotomy. So the keratometric index affects any kind of corneal surgery, refractive surgery. Error number 2, the measurement radius error. If you see on the left an eye with a radiokeratotomy, and here the measurements are taken in the wrong place, because if you have a measurement taken along a diameter of about 3 millimeters, 2.5, 3 millimeters, this may be taken out of the optical zone. While if you look at the right, you have a LASIK with a rather large optical zone. The measurements are taken in the right position inside the optical zone. So this is an error that happens almost always after radiokeratotomy, but can happen also after excimer laser if the optical zone is small or decentered. And we previously demonstrated that if you have an optical zone of around 6.5 millimeters, this problem does not exist anymore. Error number 3, which was discovered, highlighted by a Spanish ophthalmologist, Dr. Aramberry. He realized that the old generation formula back in 2001, they were the gold standard, the Hofer Q, Holiday 1, Holiday 2, and SKT. They predict the position of the lenses, the so-called ELP, from axial length and from corneal curvature. Of course, the prediction is no longer valid if we change by excimer laser the corneal curvature and power. You see here, for example, you have an eye with a pre-op K of around 46.5 and you have the right ELP prediction. But if you flatten the cornea with any technique and it goes down to 37, for example, of course the prediction will be wrong. So every millimeter of error in the ELP on average produces about 1.4 diopters of unwanted hyperopia. And if you make a 10 diopters correction, can lead to 2 millimeters error of ELP estimation, which translates in almost 3 diopters of hyperopic surprise. And which is the solution for this, the third error? First, probably the most simple is to use formulas that do not predict the ELP from corneal power. The most famous of this formula is the Higgins, and this is the reason why the combination of the standard Higgins with the total keratometry by the IOLMaster 700 works so well, because you don't have the ELP prediction error. Otherwise, you can follow the approach of Dr. Aramberry, so-called double K, which is good for the Hoffre Q, for the Holiday 1 SKT, but also for most of new generation formulas like the Hoffre QST, the K in the Barrett, the Evo. In all these cases, what does it mean double K? You take the the original keratometry before laser to predict the position of the lens, of the intraocular lens. And then you take the new one, the post-laser keratometry for the divergence part of the formula, so that the rays go focus on the retina. And this is what Dr. Aramberry called the double K. And you may ask, okay, I don't have the pre-LASIK or pre-radial keratometry. How can I use this method? Oh, okay, if you don't have any information, just using these formulas, 43.5, which can be a good average number, or 43.81 if you want to be more accurate, because this is the average value for myopic eyes. Or you can do something else. For example, if your keratometry now is 36 and you know that the myopic correction was -6, then you just add 6 to 36 and you get that you will get 42. Or even better, you can take, for example, the posterior corneal curvature for any device, including the IOLMaster 700, and with the LASIK and PRK, you can take advantage of the average ratio between the anterior posterior ratio between the anterior and posterior corneal curvature, which is quite fixed and does not change with a laser unless you have ectasia. And then you multiply the posterior radius by this ratio. For example, if you have if you have a posterior radius of 6.54, you multiply this number by 1.21, which is the average ratio of the pentacam, you get an anterior radius of 7.91. Here you should pay attention, because we know, several papers already demonstrate this, that the IOLMaster 700 provides you with the posterior radii and keratometry, which are flatter compared to all the other devices. So with the IOLMaster, you should multiply this by 1.12 rather than 21. And you may ask me, where should I enter these values? Well, the first answer I can give you is that when you deal with the new generation formulas, and for example, the Barrett, even Hoffre QST, you are allowed to enter the posterior keratometry. And this posterior keratometry is used just for this purpose. That is to recalculate, to estimate, let's say, the pre-LASIK or pre-PRK keratometry. Just to show you, when you go to the Barrett website, you are given two options. You can either just use the predicted posterior corneal astigmatism, which is a way to tell you the posterior keratometry, or on the right, you can use the measured posterior corneal astigmatism or posterior keratometry. And in fact, if you select the second option, you get this display, and you must select either the IOLMaster or the pentacam. If you select the IOLMaster 700, that ratio of 1.12 will be used, otherwise 1.21. They are not interchangeable, while other devices other OCT or Schentflug are very similar to the pentagon. So the IOL Master 700 stands alone. The same happens with the EVO. You see, again, you can enter measure posterior cornea, and you must select again IOL Master 700 if you are using the IOL Master. And the same happens with our formula, the Hoffer QST. You have two different cells, one for all devices but the IOL Master 700 and one for the IOL Master 700. So what happens if we do not correct the calculation formulas? In previous myopic treatments, you get hyperopic surprises, and in previous myopic treatments, hyperopic treatments, you get myopic surprises. So before talking about the solutions, I would like to know if there's any question from the participants so that we are sure that everything is clear. Elisa, is there any question?
No yet, doctor.
Okay, so don't be shy. If anything is not clear, just ask and I'll be glad to explain. By the way, so to conclude, there are three sources of error. The keratometric index happens in all eyes. The radius error just when the optical zone is small, and the ELP or formula error in all eyes. And so let's see which are the possible solutions. And there has been a huge literature on this topic over the last 20 to 20, let's say 25 years. There have been probably 30 to 40, maybe more methods described to try to give accurate higher power calculations. And such a big number, in my opinion, generates confusion rather than accuracy. One of the most commonly used websites has been for maybe 20 years the Ask Us website. I tell you, this is now something old that, in my opinion, plays a very minor role and should not be used anymore, because the formulas available on that calculator were mainly developed 15, 20 years ago, so it makes no sense in my opinion, and probably it will be updated soon. And many times it gives very different results between different formulas, so again, some more confusion. Over the years, I developed different strategies to solve the problem. And one of the first questions I had, can we use the same methods for all eyes? And my answer was no. It depends on what data you have. For some eyes, you have the whole clinical history, so you know the amount of refractive change, you know the pre-op K, and in some cases you don't have anything. So what can we do when we have everything, or we have nothing, or we are in the middle? We published 3 papers between 2016 and 2015 comparing these different the different formulas that were available at those times, and we published a decision tree that was very good, but this was exactly 10 years ago. So on the left you had the formulas to be used when you had all data, and on the right the formulas that should have been used when no data were available. You see that all these formulas now are almost not used anymore. They are not on the web, so they lost their popularity, even if they were quite accurate. And I did an Excel spreadsheet that I've been using, and now I'm not using anymore. Now the formulas that should be used are those available on the web, and most of them are included in the European Society of Cataract Refractive Surgery website. Although the ECRS website does not yet allow users to enter posterior keratometry, so that's why I prefer to go to the direct website of the Barrett 2K, which is available on the APRAX website, the EVO formula, the Hofer QST, the per DGS, and then there are two more options that are probably the most accurate in my opinion. The first one is the combination of the standard Hygis, not the Hygis L, with the total keratometry by Zeiss, and the second one is ray tracing. And I just want to give a little information about every of these solutions. So let's start from the Hygis, the combination of Hygis and total keratometry. The Hygis formula is accurate in this case because it does not suffer from the formula or ELP prediction error. So it does not need any double K adjustment. The predictors for the Hygis are the axial length and the anterior chamber depth. The problem of the Hygis is the corneal power. So Professor Hygis gave as his solution the Hygis L, which was an estimation. He changed it just for the IL master, not for the other biometers. He changed the keratometry according to a regression formula, and this was an estimation of the post-LASIK keratometry. With total keratometry, you don't have any estimation. It is a calculation based on measurements. It does not suffer any more from the keratometric index error. And okay, it has not been the first method to calculate the corneal power from both corneal surfaces. The Pentacam already did it 10 years before with what has been called the total corneal refractive power, the Galilei with the total corneal power, the CSO instruments with the mean pupil power, which is the big difference between the Zeiss solution and the other manufacturers. The great advantage of the total keratometry is that in virgin and operated eyes, it is equal to standard keratometry, while total corneal power from Scheimpflug cameras or other OCT are systematically lower by 0.6, 0.7 diopters. So you cannot use the total corneal power from Scheimpflug in virgin eyes because it's lower and it would require different formula constants. And nobody will ever optimize the constant just for the total corneal power. But if you cannot use it in unoperated eyes, you cannot even use total corneal power by Scheimpflug in post-LASIK or post-radial keratotomy eyes. The main difference, as I told you, of the total keratometry by Zeiss is that in normal eyes, it has the same value as keratometry, so you can use the same constants. You don't have to optimize the constants specifically for this keratometric measurement, and this is quite as simple as a fantastic method accurate to give you good IOL power calculation. And how is total keratometry obtained? It is obtained by the IOL Master 700 from the anterior corneal radii, which are measured with the telecentric 3-zone keratometry typical of the IOL Master 700. And then the posterior radius is obtained from the OCT scans that you can see on the left down. But they are fitted to each other, and finally you get the posterior radii, and from the posterior radii you get the total keratometry. The first authors, the first colleagues that investigated the accuracy of total keratometry combined with Hygis were Doug Koch and Lee Wang in Texas. In 2019, they made a comparison between the standard Hygis with standard keratometry, the Hygis L by Professor Hygis, the Barrett 2K, and the Hygis TK, and they found that the Hygis TK was the most accurate. So they were the first ones. Then a few years later, my team and with some Colombian colleagues, we enrolled a good number of eyes from Italy and Colombia, and we found that in the previous myopic LASIK or PRK, we had as many as 76% of eyes with the prediction error within half a diopter. Accuracy was a little bit lower after hyperopic surgery, 66%. So maybe you are not familiar with these percentages, but you should remember that there are many papers showing that in healthy unoperated eyes, that percentage usually is around 80 to 90%. So this means that with highest total keratometry, we are getting very close to the results of unoperated eyes. And thanks to the collaboration with Zeiss, we are going on collecting data. And here you see the last update of our sample. These are unpublished data. We have 96 eyes with previous myopic LASIK or PRK. We use the Huygens, the Eulic constants for the Huygens TK, and we compare it also to the Barrett 2K using the APAX website constants. And you see that in these 96 eyes, first of all, the prediction error was 0.01. What does this mean? That on average, the difference between the predicted spherical equivalent and the postoperative at 1 month spherical equivalent was nothing, was 0. Of course, with some standard deviation. But just using the arithmetic prediction error is not sufficient, because you know that if I operate 2 patients and one patient ends up -5 and the other one +5, the average is 0, but they are quite unhappy. And so that's the reason why we also calculate the absolute prediction error, which can be given either as the median or the mean. And in this sample, we get a median absolute error of 0.22 and a mean absolute error of 0.28 diopters, which are excellent results, with as many as 78% of eyes with the prediction error within half a diopter. So very close to 80%. This is an amazing number. And maybe you are used to consider the Barrett 2K as the gold standard, probably is the most famous, but look at what happens in the same sample with the Barrett 2K and posterior corneal power and predicted posterior corneal power. You go down from 78 to 46%. So there's no comparison. There's no competition. The highest TK is much more accurate, and the Barrett 2K gave a prediction error on average quite myopic, about 0.5 diopters of myopic surprise. Things get better when you enter the measured posterior corneal astigmatism or measured posterior keratometry with the Barrett 2K, because you go up to 67%. The myopic surprise is a little bit better, -0.37. By the way, based on our data with all measurements provided by the IOL Master 700, there's a simple solution, in my opinion, which is use the Huygens total keratometry and not the Barrett 2K, or maybe take measurements, make the calculations with Barrett 2K, but don't be surprised if you will get around half a diopter higher of the IOL. And another interesting data is the comparison between the Huygens TK and the Barrett Universal 2 in unoperated eyes. And you see that the first row is post-LASIK eyes, the second is virgin eyes. Both are myopic, and the percentage is the same. So that's why I can tell you that the combination of Huygens total keratometry is now as good as the Barrett Universal 2 in unoperated eyes. And what you have, how can you manage the Barrett? You just have to First, go to the Apex website, select the Barrett 2K, select either myopic or hyperopic or radial keratotomy eyes, and then you go to the measured posterior corneal astigmatism or curvature, as I told you before, and select the iron master 700 TK, and you get the power. You remember that on the Apex website, you also have the Barrett 2K toric calculator. So this is one of the few options to measure even the toricity of the IOL after LASIK. We also then, just to tell you that the results with the IOL master with the Barrett are not so surprising. We got similar outcomes also when entering the pentacam posterior curvature, which means that if you use just the anterior radi, you get at the bottom 56% within half a diopter, and you go up to 70% when you enter the posterior curvature. So when you use the Barrett 2K, please always enter the posterior corneal astigmatism or posterior keratometry. The formula that we developed is called the Hoffer QST, where S stands for my last name and T is Dr. Taroni, a young colleague that made most of the job. And we had to fix, with respect to the standard old Hoffer Q, some issues. The first problem was the keratometric index. So we fixed it with using this method and this formula. And then we used the double K approach to correctly estimate the position of the IOL. And for doing this, we offer 4 options. First, if you do not have anything, automatically the mean value of 43.81 is used by the formula. You will not know it because nobody will tell you. I'm just telling it right now, but this is what the formula does. Options number 2. Maybe you're lucky and the patient came with his or her clinical chart, and you can get the pre-LASIK or pre-PRK keratometry, and you just enter in that cells. Then if these are not available, you can enter the posterior radius 1 and radius 2 from sham fluid cameras or from other OCT, or you can enter the posterior keratometry by the IOL master 700. So this is what I told you before. Once corneal radii are entered, they are used to estimate the pre-LASIK PRK and the pre-LASIK and pre-PRK anterior curvature. And which are the results of the Hoffer QST? Well, if you do not enter the IOL master posterior keratometry, you will get 60% of eyes with the prediction error within half a diopter. If you can enter the posterior keratometry by the IOL master, you get 76% of eyes within half a diopter. And you remember that with the Highest total keratometry, you were slightly higher, 78%. But having both Hoffer QST and Highest total keratometry is a good solution. And if the results agree, you are in a good condition. The third solution is available on the web, is the Evo. Again, you can use you have to select the LASIK, PRK, or RK option, and here you get the results on of these 3 web-based formulas, and you see that you have better results when you enter the IOL master, posterior corneal astigmatism, or posterior keratometry, and all these cases provide further evidence that posterior keratometry is mandatory for post-LASIK eyes. Is there any question about this, Elisa?
Yes, doctor. I have one question from the assistant participant. It says, which adjustment should we make in patients with presbyopic LASIK?
There's nothing published about this. I've been told this, I've been given this question many times, and if you listen to Dan Reinstein from London, almost nothing has to be done, because at least you have to make the adjustments according to the kind of spherical equivalent that was corrected, either myopic or hyperopic. But the small amount of microns that were ablated to give you the presbyond effect do not have any real effect on the power calculation. But this is just theory, because there are no published studies about this. Maybe in a few years I'll be able to tell you.
Perfect. Understood, doctor. Thank you.
And let's go on with another solution, which is not new. Is ray tracing. The ray tracing dates back to more than 100 years ago, and it's based on the Snell's law, where the rays from the infinity on the left are traced through the epithelium, the stroma, the aqueous, the IOL up to the fovea, and each ray has a deviation once it goes through an interface, which is proportional to the difference of the refractive index, for example, between air and cornea, or between cornea and the aqueous, or between the aqueous and the IOL, and so on up to the retina. So it's just physical, and it has some theoretical advantages compared to the formulas I gave you the information before, because all the formulas that I talked about before are called theoretical thin lens formulas. What does this mean? If I tell you thin formulas, it means that the diopters, and specifically the cornea and the IOL, are infinitely thin lenses. So the cornea has no thickness, the IOL has no thickness, and as a consequence, even the postoperative ELP, or if you want to call it the postoperative anterior chamber depth, is not a physically measurable variable. It's a fictitious number again, which has to compensate for the keratometry value, which is not real, and the lack of thickness of the IOL. So there are a lot of assumptions that work well, but are assumptions. With ray tracing, we are able to eliminate these assumptions and work on diopters that have a real thickness. And here you see that the radius path is based on this law, Snell's law, taking into account the refractive index of each diopter. And you are not only per axial, you can take into account the corneal curvature, but also the asphericity with ray tracing, and higher order aberrations like spherical aberrations or coma. And importantly, with ray tracing, you can also change the expected refraction according to the pupil diameter. Of course, you need a way to predict the IOL position. So it represents the most logical solution, in my opinion, because it's not based on false assumptions, it's not paraxial, it does not need any clinical data, no, any historical data, but it still has some big problems. And the biggest problem is that we don't have the physical properties of most IOLs. They are proprietary information. So for ray tracing to be really accurate, you would need to know the asphericity of the IOL, the ratio of the anterior to posterior curvature. So a lot of data that are not available. And for this reason, there's still something missing for exact ray tracing. And there are different solutions. We have ray tracing developed by manufacturers like CSO. We have Oculix, which is a software developed by Professor Preussner in Germany, and this can be installed on most devices. And there's also the Olsen exact ray tracing on the Pentacam. And here you see the results on the same sample I showed before with the ray tracing available on the MS39. We had to adjust the axial length, and we used a formula which was originally developed for the Holiday 2. And by adjusting the axial length, we got a prediction error of 0.06 and 81% of eyes with the prediction error within half a diopter. So now you understand that I have 81% with ray tracing, 78% with the Heiss and total keratometry, 76% with the Hofer QST. And so whenever I have a post-LASIK eye, I do measurements and calculation with these three methods: Heiss TK, ray tracing, Hofer QST with posterior keratometry from the IOL master. In most cases, I get very similar numbers, and I can feel confident to use even premium IOLs after LASIK. And here you see again the comparison between ray tracing and Barrett. Ray tracing much better. The other solution is Oculix, the ray tracing. You see here, this is a software available on many devices. You get both a paraxial predicted refraction and a best focus, which takes spherical aberration into account. And this is the Pentacam ray tracing, actually developed by Dr. Olsen in Denmark. So,
Doctor?
yeah.
I would like to intervene in 1 minute because we have 2 questions in this moment.
Yes.
So maybe before we pass the next topic.
Yes.
Perfect. So one of the participants is saying, is asking about after refractive surgery with Barrett Trucay, Evo, Hofer, KST, the best option to minimize the error is always to use TK in all these formulas? That's
No. You don't have to use a TK. You have to use a PK, posterior keratometry.
Perfect, because the next question is about the same. Yes, is saying more or less the same. Is asking which one is the difference between using PK or TK. Okay,
this has been something confusing, and also when I talked to Professor Barrett recently, he said that he didn't want to generate this confusion because his method is called Barrett Trucay, and using the IOL master posterior curvature, he called it a Barrett Trucay TK.
Yeah.
It should not be Barrett Trucay TK, but should be Barrett Trucay PK, posterior keratometry.
Okay, then. Okay. So, that's the confusion.
The total keratometry, the only place where, as far as I remember, the only formula where you can enter total keratometry successfully is the standard Heiss on the directly on the IOL master. Is not on the web. So you get the Highest total keratometry on the IOL Master. The other formulas on the web.
Good.
Actually, the Barrett 2K, TK, or PK, whatever you want, is also available on the IOL Master.
Yeah,
But
exactly.
it's not my favorite. So
Okay.
I prefer to use Highest, Hofre QST, ray tracing if you have. Then I like the Evo more than the Barrett. But among these, the Highest TK is my favorite.
Perfect. I think with this summary is, yeah, understood already. Thank you, doctor.
You're welcome. So you can also have previous hyperopic LASIK. And in summary, I can tell you that more or less you get the same solutions. So the formats that I gave you are still valid with a few differences. Okay, if you don't do anything, you will get myopic, and we know. The formats that you can use are this. You don't see the Hofre QST because we never developed a post-hyperopic LASIK Hofre QST. The Hofre QST is only for myopic. And so do not use ray tracing, because I can tell you, even if I did not publish, that is not as accurate after hyperopic surgery. Probably because of some problems in estimating the position of the lens. So, first Barrett, second Evo, third Highest, and fourth Perdiges, just in alphabetical order. And here you see the different screenshot of these formulas. And again, my suggestion is always to collect all these 4 options and hope that you find a good agreement. Usually you can find it. Something more difficult is radial keratotomy. There are many problems with the radial keratotomy. Many times the optical zone is very small. Sometimes it's decentered. Sometimes the cornea is so flat that it goes below 30 diopters, and you cannot use some of these formulas. For example, the Barrett, but also the Evo, do not work when the keratometry is lower than 30. So in these cases, the ray tracing has been my favorite solution for many years. And in all my courses, I've always been telling that ray tracing is the way to go, and this is probably true. But I just finished writing a paper which still has to be submitted. So please take this like a very preliminary information. I can tell you that with ray tracing, I get about 60% of eyes with the prediction error within half a diopter. But with these other options, the Barrett 2K, Evo, Highest TK, and PerDGS, you are around 50 to 60%, not so far from ray tracing. I thought they were much worse, or probably that ray tracing was better. So after collecting not a big number of eyes, 20 eyes, but I did all the calculations in October, I wrote the paper in November, I hope I will submit it in December. And I can tell you that the accuracy is slightly better with ray tracing, but with not such a big difference compared to the other methods as I thought. And the results are much better when the axial length is lower than 26 millimeters. So if you get a radial keratotomy in a relatively short eye, because maybe the myopic error was small, the results are quite good. But when you go to 28, 30, 31 millimeters, even with all these formulas, the results are not yet very good. And that's also, maybe we can take a little break Elisa? Oh, but I'm ready for any
Yes.
question.
Yes, doctor, I have another question, if you don't mind, before the break. So,
Let
because
me
it's,
go. I want to. Okay, let me see. Okay, you can
Mhm.
see.
Yeah, I can see you now. So the next question is, how is possible that we have better results using ray tracing of Sirius in post-LASIK than in virgin eyes?
I don't know, but I also saw this. So I'm not using the ray tracing by Sirius or MS39 in unoperated eyes
Mhm.
because standard formulas are better. And the results, while the results in long eyes with ray tracing are good. So I do not have a clear answer. I collected the many eyes, but I did not have time to make a clear analysis, but I have already some preliminary idea. In my opinion, this depends on a wrong estimation of the IOL position when the anterior chamber is crowded, or at least is not as wide as in myopic eyes. If you have a long eye, you have very wide spaces in the iridocorneal angle, and you know that the IOL position with the CSO instruments is predicted from the scleral spur to scleral spur, the iris angle, and so. It's a proprietary method. I don't know exactly how it works. Nobody knows, just the engineers of CSO. But I've been told many times that it depends on the position of the angle, the position of the iris.
Mhm.
So if the anterior chamber angle is crowded because the eye is small or normal, not small, normal eye, I believe that the position of the IOL is not correctly predicted, and so ray tracing fails. So this is why I did not include the ray tracing as one of the possible solutions for post-hyperopic eyes. But I don't even use it in healthy eyes, just post-myopic LASIK and post-RK.
Perfect. We have another one, and it's saying Shamas Cook is useful in post
Yeah,
hyperopic.
but not as accurate, in my opinion, as the Hygie's decay. Okay, it's an
Mhm.
improvement over the original Shamas PL, which was a very important solution for many years because it was the first no history formula. But it was, compared to the Barrett, it was less accurate compared to all the other modern formulas. The Shamas Cook has been improved, but I had some preliminary data and it's not the best. So I'm not using. I do not have yet a formal analysis, but my impression is not as good as the Hofer QST, the Hygie's TK, and the Evo, and also the PER-DGS.
Good. Furthermore, it's saying several studies have been published with intraoperative aberrometry in post-myopic and post-hyperopic. It is useful.
In my opinion, it's too expensive to be useful. It's not. I never use it because it's almost not available in Europe. I think that
Okay.
very few surgeons had the opportunity to test it. While it's very common in the United States, it gained no popularity here. And yeah, I think that the results more or less are close to those available that can be obtained with the other formulas I talked before. But you still need an optical biometer to measure the axial length. So you need to buy the IOL master. And once you have the IOL master and you have the IGSTK, and you can use the IOL master measurements and enter them in the Barrett, Evo, OverQST per DGS, why do you need to spend I hate that Alcon will not hate me, but why do you need to spend 60,000 euros? I think that the price more or less is that one, just to calculate the IOL power. You already have
More
other
solution.
solutions that are included in the IOL Master and also in the, no, not the Argos, because the Argos does not have posterior keratometry. By the way, in my opinion, is not worthy. It can be good to orientate the IOL, the toric IOLs, and to refine some adjustments, but in my opinion, the IOL Master is better.
Perfect, doctor. Speaking about expensive or no, as well as asking if ray tracing is free.
Free?
Mm-hmm.
I don't know. I think that once you buy, any optical biometer which allows you to do ray tracing, probably you have to pay a little fee. I think that with the CSO, it's like an optional. Probably you have to pay a little bit more to get the module of ray tracing. I'm not sure. And the same happens when you buy the Anterion and you ask for the Oculix, or the Galilei G6 and you ask for Oculix, but I don't think it's very expensive.
Good.
It's
Perfect.
more, the MS39 is expensive. So once you buy the MS39, you maybe you ask the dealer to give you the ray tracing for free.
That's a good solution then. We have here as well that one participant is saying most of the studies don't report the formula performance index. And do you consider, doctor, that it should be reported in studies assessing IOL formulas?
So and so. Well, I'm quite proud because I was the one that resurrected the formula performance index in an article that I wrote with Dr. Hoffer in 2020. The original idea of the formula performance index was given by Professor Hygis 1 or 2 years before he passed away. So he never published it. But I remember that he talked about it in a few meetings. And then once I went to the ECRS website, where there is a learning section with all the talks of the last few years of the ECRS, and I was able to retrieve the formula performance index with the original talk given, I don't know where, in Copenhagen, in Amsterdam, somewhere, by Professor Hygis. So at that time, I thought like any idea by Hygis, it was simply great. And I think that when he introduced it, it was probably 2013 or 14, it was the best metric. And that's why I included it in the paper I wrote. It's the best metric because it takes a lot of parameters into account, including the correlation between the results and the axial length and so. But for all my studies, I use the website developed by Professor Abulafia, which is called Itemis. It's better because it gives you a lot in a very few steps, very easily, all the statistical comparisons between two or more formulas, and evaluates the prediction error, how far is it from zero. It includes the standard deviation, and it also includes the absolute error. So it gives you an overview with statistical significance, and this is the way I go because it's very easy. The other method that can be used is the heteroscedastic method test developed by Wilcox, Holliday, Wang, and Koch in the United States. You need R, which is a free software. You can download it. and now it has several versions available on the web. The main problem are that the first time you try to use it, you have to spend 1 or 2 days to try to understand it. I did it some years ago before Itemis was available. I wanted to test it, to use it, and I learned how to use it. But it took me really a lot of hours. So, and once I learned, it was easy. It became automatic. Then I did not use it for 3-4 years. And should I start again, I would probably need 1 week to learn it. So, in my opinion, Itemis is the best way to compare the accuracy of different formulas, better than the Formula Performance Index.
That's good. And did you say, sorry, that was for free?
What?
That one.
Itemis is for free.
Yeah,
You go to itemis.com and it's completely free. And it gives, in addition, a lot of results for spherical equivalent, for toric IOLs. There are many available options.
Good. So, and doctor, I think that before going to 5 minutes break, I think that it's important to answer this question is as well like a little bit a summary about what we was talking before about TK. And I think that that is the main confusion for our participants. So I'm going to tell you again the new questions. So the participant says, in conclusion, with the IOL Master 700, we use TK instead K for patients that had prior myopic or hyperopic LASIK, right?
Yes, on condition that you use the Hygis.
Good. For
You
Hygis
cannot
TK
use
and Barrett
total
TK.
You cannot use the total keratometry with the Hoffer-Q, Holiday 1, or SRKT because you fix the keratometric index error on the cornea, but you don't fix the ELP prediction error. And in addition, there's also a little trick. If you, on the IOL Master 700, if you select previous laser vision correction, you are automatically driven to the Hygis R. You have to tell the IOL Master 700 little lie. Just tell the machine that this eye was not operated. It was a virgin eye. So you are allowed to use the standard Hygis with total keratometry. So Hygis and total keratometry. Or on the IOL Master, if you are lazy and don't want to go on the web, you go to Barrett through KTK or Barrett through KPK. This is given automatically, but it's not as accurate as the Hoffer-QST, as the EVO. I still have to make a fair comparison to the per DGS. So, in summary, if you in your office you have the IOL Master 700 and you have a post-myopic LASIK eye, Hygis TK, Hoffer-QST, EVO, per DGS, and Barrett, always with the posterior keratometry, always. And I can tell you that the posterior keratometry of the IOL Master gives you slightly better outcomes than the posterior keratometry of some Scheimpflug cameras. If you have a post-hyperopic eye, same story, same formulas, with the exception of the Hoffer-QST, which does not exist for hyperopic eyes. And finally, it's so simple that the same formulas are still the best also after radial keratotomy. So you have 3-4 formulas that do not require any historical data. You don't need any more to know if the patient was -6 or +4. This is an old story. You don't need those data anymore. You need the posterior keratometry by the IOL Master, which will fix the lack of refractive history.
Perfect. Well, doctor, so really interested this first part. If you don't mind.
I don't know if the participants want to make a break because actually I have 3 cases. I can go on. I
Yeah,
have just 3 cases, and uh, I can show them if you give me again the opportunity to share, because it will
yeah, for
take
sure.
10, 15 minutes. And it's not okay. So everybody is
Who's,
still there, and
yeah,
let me go on the full screen, and okay.
yeah, I
I
can
think
see
that
you
we can
now.
do it in a
Perfect.
relatively short time. I just want to show you 3 recent cases I did. These have been are quite recent over the last couple of months. One post myopic LASIK, one post hyperopic LASIK, and one post RK. So this is a young man, 54, myopic LASIK 15 years ago. This was a very early cataract. You see that the corrected distance visual acuity with a slightly hyperopic refraction was still 20/20, 1.0. But anyway, the patient was complaining, was hyperopic, and what you see the map on the right. So and this is the let me see, the left eye. So you go here, and let's have a first look to the average keratometry and the average total keratometry. I told you that in virgin eyes there's no difference. This is typical of total keratometry by Zeiss. Here there's half a diopter of difference, which is the best, the better value to be used. On the right, total keratometry. So you don't have any more any overestimation of K, leading to subsequent hyperopic outcomes, underestimation of IOL power and final hyperopia. So you keep this 35.98, and then you have a look on the 4th page, usually, of the printout of the IOL master, at least in my office. You see the posterior keratometry, PK1, PK2. On the left, you can see the usual map and the Myers of the IO master. And you enter these values. The first row is wrong, of course, but I did it on purpose. So the Barrett Universal 2 with keratometry, but without any adjustment for LASIK, gives you 19. Then you use the other formulas, the Barrett, the Higgins TK, EVO, Barrett and even Alfred QST with the posterior keratometry and per DGS. And this is what usually happens. You have most formulas close to each other, 21, 21, 21.5, 21, 21, 21. Then I did the ray tracing. Here you see all the screenshots tell you 21. Then you do ray tracing. Ray tracing is a little bit different, 20 and 20.5. Of course, if I have a 5, even if ray tracing is very accurate, if I have a 5 formulas out of 6 showing me 21, I implanted 21. This was a 21 VVT, and the final refraction was minus 0.5. So maybe 20.5, as suggested by ray tracing, was a little bit better. But if you make the prediction error, which is the difference between what you predict and what you get, you see that the prediction error is very low with all formulas, including the Barrett, all within half a diopter. So very successful predictions, and the patient was happy. So this is again the demonstration that you have to use these formulas and you are done in most cases. And this is the second case with the hyperopic LASIK. Again, the patient was still hyperopic with a clear lens not 2020, some hyperopia, young patient. So this was a real clear lens extraction to correct the hyperopic residual. Short eye, again the left, you see, in this case, the difference between K and TK is the opposite, because this was an hyperopic eye. And you get slightly higher values with the TK rather than K. There was some astigmatism. You see the posterior keratometry to be used for Barrett, EVO, and Hoffrey QST. Not Hoffrey QST because this is hyperopic, just Barrett and EVO. And here you see that, again, most formulas, with the exception of the EVO, were between 25.5 and 26. EVO was slightly lower, but I still feel confident because I have 3 of them very close to each other. In this case, even ray tracing was good, even if this is not my favorite with the hyperopic eyes. So I decided to implant at 26. I was lucky. At the end, I was plano. But I had the most formulas showing me 26. And again, the EVO, all formulas were good, but the EVO. So again, it's worthwhile to use 4 or 5 formulas. And if you have an outlier, discard it. Then maybe the outlier was right, but in most cases it should not be. Okay, the last case is a radial keratotomy with the real cataract and hyperopic shift 2.5. And again, here you see the difference is small between K and TK. The K is not too flat. Sometimes you go under 30, as I told you. Again, you look at the posterior keratometry is very, very flat here. After LASIK, you were around minus 5.5, and here you are minus 4.5. And fortunately, all the formulas were close to each other, around 25. Ray tracing, which should be the best one here, failed because in one case you had 26 and the other one 23. So I was a little bit afraid. I relied on I stayed in the middle, but the standard formulas were better. You see that in this case, ray tracing was the worst one. So you never have the certainty to get good numbers. In my opinion, it's always better to evaluate different formulas, and at the end you see that the formulas are always the same: the Barrett, Higgins, EVO per DGS, and Hoffrey QST for post-myopic. And that's all. So is there any other question?
Yes, yes, doctor. About the first case, one participant is asking if your measurements always match as this first case. In case that if not, which formula do you finally use?
In those cases, I go with my statistics, for which I have only for myopic eyes, not for hyperopic. For hyperopic, I pray a little bit, and also for radial keratotomy, I say some prayers. But for myopic eyes, which are the most common cases, I've been collecting cases for 20 years, and I showed you the results for the last 96 eyes. That are the cases I collected since I had the IOL Master 700. I have older cases, but they were measured with other biometers, so I don't use them anymore. So my ranking is the following. First, the same level, ray tracing, and Higgins total keratometry. third, Hoffer QST, fourth, Evo, close to Evo per DGS, and last one, Barrett. So if they are all different from each other, I stay on the top, on the one that on average gives me the best outcomes. But trust me, this does not happen, at least after LASIK, does not happen so much. Especially if you use the PK to improve the prediction of the IOL position. So I think that compared to about 5-6 years ago, we are in a much better situation because all these formulas, in most cases, match to each other. So the big problems come when you have a small decentered optical zone. In those cases, you have to make it maybe to repeat many measurements even with the IOL master, because if you have a very small optical zone, you can get bad measurements also with the IOL master, even if the inner ring of the telecentric keratometry is quite small. But this is the way to go. And so one of the main, when people ask me why should I, which biometer should I buy, of course, if you want to buy the cheapest one, the IOL master is not the answer for you. It's not the cheapest. Is not the most expensive, but is medium high. But if they ask me why, the reason is total keratometry, because in my opinion, for post-LASIK eyes, it makes a difference. Of course, I would like to have a bigger placido disc on the IOL master. Yes, I would like. I would like to have a better anterior segment of CT. Yes, but you don't care so much. These are not mandatory requirements for accurate power calculation. They are more qualitative assessments that can be useful, nice, but if you want to get to the final result, the posterior keratometry and total keratometry for post laser eyes are at the top.
Good. Doctor, with this question as well is too similar about something that we was talking before about Argos. So one participant was asking about if Argos hasn't got a PK, do you consider, doctor, to buy another extra device to make sure that we are taking these kind of measures in these patients?
Absolutely, yes, but of course, the IOL master gives you everything in one device. But if you have the Argos and you want a PK, you can either buy a Shenflu camera or anterior segment or CT, and you need it. But when you do refractive surgery, you need a device measuring posterior keratometry, because you need the tomography to detect early keratoconus, and so it's likely that you have it. If you just do cataract and you don't perform refractive surgery and you don't have a Shenflu, it would be better to have it. But remember that no, if you have the Argos only and you don't have posterior keratometry, you are in a bad situation for post-LASIK.
Let's say.
In fact, the Argos has the field to be filled in with the PK. You have to take it from another instrument, but when you do Barrett through K with the Argos, you are told, do you want to enter posterior keratometry from another device?
And you can do this yourself. Good. And doctor, an interesting question is saying, when the patient has done LASIK, previous LASIK, and keratotomy, radial keratotomy, how do you do this calculation? As so LASIK or keratotomy?
Together in the same eye? This is, I think that in this case, no, it's not so difficult to give you an answer. In these cases, the only solution is ray tracing. Ray tracing, because ray tracing doesn't care about the history of that eye. you can have done RK plus PRK plus LASIK plus epikeratofakia plus corneal transplantation, some cross-linking, whatever you want. Ray tracing just goes with the curvature, while standard formulas always have some adjustments that are derived from training data sets used to develop the formula. So that's why you cannot use the Hofer QST after radial keratotomy, because we used LASIK eyes. I did not have enough RK eyes to develop an Hofer QST for RKs, post-RK. And even if they are not published, I'm sure that the Barrett for post-LASIK is different compared to the Barrett for RK.
Good.
So if you have both together, there are no formulas published for these eyes, you go with the ray tracing.
Perfect, doctor. I have another more here. In low-income resources with no PK and with no previous history, which formula will you recommend in post-myopic and post-hyperopic, Barrett 2K, no history?
Yes, of course. But again, though, use the same formulas I told you without PK. You know that they are less accurate, but still much better than the old Shamas PL or the Hygis L. So I sometimes I get emails from colleagues that just have the Iron Master 500 or other old generation devices, and they just give me K, anterior chamber depth, and axial length. If this is the case, I usually make calculation with the same formulas I told you without entering the posterior keratometry.
Good. Good. So, doctor, yes, the last question, because I know that we was talking about this, but I don't want any participant to get lost with this concept. So please let me say again or ask again about if PK and TK in IOL master are the same concept. That's the question.
They are not the same. PK is posterior and TK is total. Then of course they are connected to each other, but TK was originally developed for something that has never been used. So total keratometry was developed for virgin eyes, based on the assumption that it may be different sometimes and maybe better. But this has never been demonstrated. 1 year, no, this year, at the beginning of 2025, with a multi-center study, we published a series of more than 100,000 eyes, 100,000, a lot. And we discovered that K and TK have a difference higher than 0.5 diopters in just 0.4% of the unoperated eyes. So the original aim of Zeiss to use total keratometry for virgin eyes, unfortunately, has not been demonstrated to be useful. But thanks to the idea of Doug Cock-Lee Wang in the United States, Zeiss found itself with a wonderful solution for post-LASIK eyes. So TK has to be used with the standard Hygis for post-LASIK eyes. Posterior keratometry is used not for the Hygis. You don't know where to enter posterior keratometry in the Hygis. There's no space, no room.
Not option.
Posterior keratometry has to be entered in the specific fields of the websites of the Evo, Barrett, and Hofer QST. And maybe some other formulas, I don't know, but this for sure. The Pearl DGS, not yet. Maybe one day, but not yet.
Perfect. It's important, this concept. That's why I wanted to ask again, because I want the audience to have
but
clear.
Also Barrett is confused about it. Well,
Yeah,
got Yeah, Barrett TK, 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 TK.
Okay. Yeah, to be honest, it's a little bit confusing. So it's normal that we have a lot of questions about this topic. So yeah, but doctor, I will stay here and receive maybe more questions. In this moment, we don't have any more questions, and for sure, I want to invite our participants, if they have maybe another question of the day, they can send it to me, and I will get to you and answer you or ask you about this kind of doubts that maybe they can have. I would like as well to say thank you because it was a really practical session.
My pleasure. Thank you very much. It was a really pleasure to share this. And if anybody wants to come to Bologna on January
Yeah,
16,
that's something that I
this,
wanted to ask you.
this is
Yes.
I didn't add any advertisement of my course, but this is an international course on January 16. It's in English. It's
Mhm.
a 4 hours course with Adia Bulafia, covering each topic on IR power calculation. And you see, if you want to get information, you see that, I don't know if you can read my email, giacomo.savini@startmail.com,
I
right?
can send it to the
And
participants
you
with
give
the
me the
video.
information.
Mhm.
Zeiss is a major sponsor of the meeting. There's a session about the IEL Master. There are some industry symposia, and it's just one day in Bologna, which can be easily reached by flights. It's connected to all European cities. So you come to Bologna. Okay, it's the worst time of the year, January, but the city is nice.
And it's not Christmas light as well in that time.
So January in Bologna is awful, but the city is still.
I'm sure that most of our participants would like to be there. So I will send with your video as well your email in case they need more information about the course
Of
and
course.
maybe they can join the course as well. So, Doctor, thank you very
My
much
pleasure.
as well because was really practical, and thank you for accepting this educational initiative for all our professionals, international and national, because we have participants from everywhere. So
Next year we do it again.
yes, for sure, for sure.
Okay. Okay. Thank
Thank you,
you.
Doctor. Take
Bye.
care.
Good evening to
Bye.
everybody. Bye. Bye. Bye.